All right, good morning, everyone, and welcome to our little presentation here on building out your infrastructure technology for central stations. This morning we've got Josh Greco from DICE and myself from OneTel. I won't go into too much detail about Josh and myself. I think most of you know who we are. We've got probably the 30 or 40 years experience in the central station between the two of us on software, receivers, and telecom. So this presentation, we're going to look at data redundancy. We're going to look at server redundancy, network redundancy, site redundancy, and then we're going into some telecom redundancy as well, and data. And with that, I'll hand it over to Josh.
When we designed the presentation, we thought we'd start off from inside the machines to the network, to the site, out to telecom, as we kind of go through this. And so there's a lot of sections to cover, so some of these are going to be very 50,000 foot as we get through these particular parts. We're saving a large section at the end for Q&A, all right? Under data redundancy, we have RAID and non-RAID based storage. I'm sure most of you are familiar with RAIDs inside your facility and the redundant amount of data, how it's kept. What am I using the RAIDs for? Fault tolerance, speed, efficiency, failure rates, things like that. Now, on the data storage side, RAIDs are used, as it says, there's an alternative affordable option versus storage area networks, large SANs, fiber systems, and things like that, to get you high I/O out of the systems versus the large fiber SANs that cost in excess of $70,000, $80,000. So the data here is laid out in something like this, where you have several RAID pens that replicate each other throughout either one machine or multiple machines as it replicates itself. So if you have a particular failure in a certain area, you don't have data loss. Now, in this particular scenario here, there's a tertiary data store, and as you can see, it's set up to where you have multiple people or end users that can access any particular data store simultaneously. So if there's a failure of one on that, the load balancing goes to the other particular data stores. So in this particular section, quick yes, but is your data kept in a redundant state? Do you keep it anywhere off-site? How do you verify that data as it goes off-site for integrity? Is it good? Am I backing it up? And how often am I backing that data up? So if I needed to utilize that data, how far back have I gone? In areas of central station, this is of a particular note because the frequency of data entry changes and things like that happen at such an expeditious pace, frequent backups are almost necessary. A day's worth of data entry loss is pretty bad. So a lot of the centrals we deal with use real-time replication to other facilities and other sites. Under the server redundancy section here, we have a certain kind of redundancy. You have standalone, failover, and server clustered. Standalone is self-explanatory. One machine may have some RAIDs in it, but if the machine goes down, you lose production off of that. And a failover or nth node replication here is much like what we all know what UL mandates us to do. Have a primary, have a secondary, a tertiary, or a quaternary server to take these failovers. A downfall to that is when the failovers happen, the secondary, tertiary, quaternary servers aren't necessarily having all the services run. A lot of replication that works this way doesn't allow secondaries to actually run until you fail over to it, so your window of failover there gets increased. In the area of server clusters here, what you have is you have multiple servers all working simultaneously. So in lieu of the failovers here, getting your in-node redundancy, there's no load sharing. So whatever the network speed, processor speeds, things like that in the machine is, everybody's bottlenecked to that, and it causes slowdown, especially in multiple site centrals. So moving into a clustered redundancy here, you use multiple servers simultaneously that all take a share of the load. So as you have 20 people accessing a server cluster, 5 might be on server A, 5 on B, 5 on C, 5 on D, hence increased performance without the expense of heavy hardware. If one of those clustered servers goes down, the users go to the other 3 available servers without a productivity loss. Now, this basically shows what clustered environment does. And then it goes on where if you have a failure on server B, as you can see, the load automatically shifts to the additional servers left in the cluster. So you ask yourself in the area of redundancy, what kind of redundancy do I have? How is it supported? What is my maximum amount of downtime? What is the quickest I can get the secondary backups back up? And do I do any testing on this? What's the frequency of the testing? How do I know it works? In the area of network redundancy, this starts to get a little more complex in the first two sections here. Networks are laid down in several different topologies, all right? And the redundancy built in those topologies is of utmost importance. Here, as you can see, we have your standard 6 layout of networks: star, tree, ring, fully connected, bus, and mesh. Now, pretty much everybody in here, it's most common, has the tree layout, where you have one switch coming off another switch, sometimes coming back to a core router. So in the tree layout here, just the most common. It's cheap, it's easy to deploy, you can scale your network relatively quickly by just plugging one switch into another and giving yourself more additional ports. The problem with that is that one mother switch, that head-in switch that's running, if that goes down, you lose everything under that tree or the subordinate nodes that rely on that particular part of the network. There's also no load balancing available. So what you have is, I got a gigabyte network. Well, all your clients down at the bottom are all hooked up gigabit into a gigabit switch. That 5, 10, 15 gigs everybody's connected to bottlenecks down to 1 gig. Then that 1 gig bottlenecks again down into another 1 gig. And so you have a geometric division of the bandwidth as it goes through the network here. So if you do have a single point of failure, you actually lose part of your building. Now, in a mesh topology on networking, it's becoming much more popular these days. The mesh topology is more expensive to lay out because you have additional hardware, a little stronger equipment than what you're going to typically find. Now, much like the server redundancy in a mesh network, the clustering goes hand in hand with this, where you actually have a mesh that lays out with multiple voters or end users at the top, going through redundant switches, down to redundant routers, through another set of redundant switches down to your cluster. The reason why this is used is if you run into a failure, on this particular side we have failures on every layer. And as you can see here, the failures on every layer still reroutes traffic to the additional servers that are left in the cluster. So here, out of 4 failures in this small mesh topology, you still have complete connectivity and workflow within your organization. So in this section, you want to ask yourself, is your network prone to these kind of failures, more or less in a tree topology? What are these single points of failure? What can be done to negate these single points of failure or completely eliminate them? Whereas, do I just keep cold switches on standby? Do I keep hot switches on standby if mesh isn't available? Is it, do I need boots on the ground at 3 in the morning if something like this is to happen? Or can I automatically move these things over remotely if need be? And then, what can you do to add the redundancy into your network based on a tree? Oh, I've seen other centrals that run 2 tree networks and just dual NIC it because it's the easiest, cheapest way to have that form of redundancy. And that gets more like round-robin DNS and things like that as you start to automatically resolve through multiple networks and node that you need to attach to. Under the site redundancy side here, of course, we go back to a single point of failure, the single brick and mortar. All right, and you typically have a set of IP addresses from an ISP that only points to your building. So now we have IP routing issues with panels and things. If you're running your own mail servers, web servers out of your facility, what do you do with that when it goes down? You can't just forward it like a phone line, and that's a problem. So a lot of people say, I'm going to get 2 internet connections, I'm going to get multiple carriers, which is great, and you can do that, all right? And when you have the multiple carriers, you still have the addition of, I have one IP set here, one IP set here. So a lot of IP panels do a primary and secondary IP. You can set up multiple A records and X records for your mail and kind of make it work to a certain extent. But when you bring in these multiple carriers into your building, just going from Charter to Comcast or Covat or whatever carrier doesn't mean you're redundant. A lot of the carriers will use the same point of presence within the city. So leaving your building, the local POP may be just down the road, where it may be Sprint, Verizon, Comcast, Charter, all use that same POP. So if that single POP goes down, you lose both your carrier connections at the same time. So when you drop separate internet connections in your facility, it's very important to ask, Where is that point of presence outside my building? How far is it away? How is it leaving my building? A lot of people throw separate demarcs into their building in different locations, so if they have a fire in one part of the building, all their demarcs aren't completely ruined. They have additional power over here, different battery backups, to have that kind of redundancy within their own facility. Now, when you get to internet connection, to start to say, so I really need to solve this IP issue. How do I get it to other facilities? How do I utilize these other internet connections, all right, as you have this problem? So BGP, Border Gateway Protocol, is really the only way on the internet to have this kind of redundancy, to move IPs from one side to another, one carrier to another, one building to another, as it flows across the country, across routers within the same building, down the block. Now, BGP is something that is any internet compatible router can, any internet connection can use. You need a BGP compatible router. And so what you do is you obtain autonomous systems number, and that can be done through like the Internet Assigned Number Authority. It can be done through ICANN, it can be done through ARIN, where you pay about $100, you get your AS number, and you get a whole /24 to the internet, and you use your existing internet connections to broadcast your BGP subnet. So you have IP subnet A and B, then C comes in, and when C comes in the BGP subnet, you no longer use A and B, it's just used to route the BGP. So this becomes your all of everything, and you can take that subnet space and move it wherever you need to. So if you have these kind of failures in a disaster recovery business continuity plan, you can make up for this. You can have your phone lines move over that Sasha will talk to, but now you can also move your internet connections to a different location. So the IP alarm panel in this scenario now, it both looks at it as the same connection. It's just one IP, and it will bounce from either internet connection, so the IP panels don't know. So any of the older legacy IP panels that don't have a primary and secondary, this help fixes that issue, as well as your mail issues, MX issues, web records, VPN connections, things like that. So in BGP, you think, I still have a single point of failure with the routers. Well, HSRP, Hot Standby Routing Protocol, is a protocol used to have both routers running BGP up simultaneously. And what that allows you to do is, if you have a primary router failure, the secondary simply takes over all the capabilities of the primary and vice versa. So you actually have a real-time redundant failover system sitting on your routers to route this traffic. Now, beneath these BGP-compatible routers would be what's known as your edges, or your head-end routers, your other Cisco routers, your SonicWalls, your Netgears, Edge networks, things like that would plug in underneath this. So here, what we did under site redundancy is we have two facilities, both running BGP with dual compatible routers. So what this allows to do is a four-site failover, where I'm tossing the BGP between my primary and secondary internet connections at site A. I go down once, it moves over. That site goes down because I have a geographical issue. The BGP automatically routes to the second facility under primary internet again. You have a third failure, and it moves to the fourth. So in situations like this, I've seen data centers that haven't gone down in over 10 years out to the cloud because of this setup here. So the question is, what capacity with the multiple sites can you utilize BGP? Is this something that's advantageous for your company? And if you have a second site, can it be arranged to utilize that second site? And what's the migration path to get the traffic to the BGP subnets to obtain this kind of redundancy? So on a top-down overview here, you have your two sites, your BGP-compatible HSRP routers, going back down into your intermesh network lattice. In the table of nines, this kind of setup that we grade network uptimes will get you 99.97% uptime guaranteed because of the level of redundancy that comes into it. So you literally have 8 different RAIDs of data at the bottom going to triple redundant networks, HSRP routers going up, 4 internet connections. There's going to be some cost to this to the COs, but the real question is how much do you want to pay for not getting put through pain? And that's the real question, is how painful are these downages for you, and how much money is it worth to you to pay to not feel that kind of down pain, lost dealers, lost accounts, things like that. So on the telecom side there, I'll pass it off to Sasha.
All right. Thanks, Josh. chair.
We'll tuck back here.
All right. Let's see how much time we got here. We got lots of time. All right. So now we talked about or Josh talked about servers, networks, redundancy for within the central station. Now we're going to talk a little bit about outside of the central station. We'll talk about telecom checklist questions first. I'm going to go through a bunch of things that you should be asking yourself as well as asking your provider first when you're looking at telecom. So, are the monitored alarm panels that you're monitoring, are they programmed with DID numbers or toll-free numbers or both? That's going to make a big difference, okay? Are your telecom circuits going through a PBX or channel bank or POTS lines to your receivers? Okay, some central stations have got multiple. Some are doing just PBX, some are doing just channel bank. I've seen all different versions of that. You want to ask yourself what kind of PRIs, if you're using PRIs, you're currently using, or are you talking to your provider about? How many people in the room here know that there's a difference between PRIs, local and LD? Did anybody know that? A few people? Okay. And that's a very big one because with local PRIs, if you've got toll-free numbers being pointed to DIDs on a local PRI, how many people in the room? Put your hands up if you're doing that today. Couple. You're paying a lot higher long distance rates because it's then considered switched long distance. Okay. So, and when I say a lot more, probably double, sometimes triple. Okay, depending on where you are. So that's a big, big difference. And if you're doing a lot of toll-free traffic or monitoring toll-free, it's a lot cheaper and it's a lot easier to use long-distance PRIs for that than using local PRIs. More than one telecom provider be used in your situation. So the key here is you want to start to diversify. In the central station for years, everyone's looked at making sure we have redundant receivers, redundant servers, redundant hardware, generators, and so on. But really, telecom redundancy has really been lacking in the central station as a whole. Okay, and it's very difficult to do this if you're dealing on the retail side of telecom. So if you're dealing directly with like an AT&T, you're not going to be able to really get redundancy. The wholesale side's a lot different. The wholesale side allows you to start using multiple providers, bringing into your central station, so you've got that redundancy. Okay, that way when one provider goes down, you've still got the other provider as a backup, and it can be seamless if you've got it set up right. Okay. How many people in here in the room in the last year have had their telecom provider go down, one of their major providers? Okay, about half of you. All right, I've been seeing a lot of that lately. Can they forward DID numbers for redundancy? This is a hard one and tricky one. It's really easy to reroute toll-free numbers. It's not easy to reroute DID numbers cost-effectively. What last mile redundancy is available? So last mile coming into your building, okay, even if you have multiple carriers, if they're both coming in on the same 50 pair or 100 pair copper cable in the building and a backhaul goes through that, you're kind of done, right? So you got to look at your last mile redundancy. Do you have fiber in the area? We've got customers that will use PRIs over fiber and telecom or copper, or they'll use multiple fiber routes if that's available. It all depends on where your central station is and what's available. What does a building platform look like? Okay, building platform is really big in the central station. A lot of your calls coming in, if it's toll-free or short duration, right? Contact ID is very, very quick. You're probably about 6 seconds, but if you're being rounded up and paying for 30 seconds or a minute, that adds real cost, okay? So there's a lot of cost savings there. Short duration penalties. Anybody in this room ever have a provider talk to them about their short duration calls or penalties? Anybody yet? No? All right. I'm surprised. So this one here is a new one. Larger central stations, the really large ones, are starting to be hit with this one, and credit card companies. The telecoms are now starting to charge extras for short durations because of those really quick on and off calls are 6 seconds long, 8 seconds long. So some of the larger centrals are starting to get hit with actual additional fees for short durations. So you got to be careful with that as well. Redundancy options does your PBX and channel bank have? If you're putting all your PRIs through the PBX, do you have redundant PBX? If so, does that redundancy have automatic redundancy? Is there downtime and switching? Same with the channel bank. Is it a hot, cold system? How does it work? Look at advantages as well of a PBX over channel bank. The big one is if you're monitoring two-way voice. If you're monitoring two-way voice, depending on the automation you're using, it's going to be a lot easier to use a PBX than it is a channel bank. Most channel banks don't support hook, flash, and transfer. That's where PBX comes into play for your two-way audio. And does your automation have integration with the PBX? A lot of the automation companies today are now integrating with PBXs. The great thing there is you can do all kinds of things like caller ID injection, when a call comes in, pulling up the customer record right away so the operator knows who they're talking to, and that kind of stuff. So first what we'll do is we'll look at a single site central station, and what I put up here is just a diagram of what's possible, okay? So what you can have in a single site here is, in the cloud there, you can have our toll-free network, okay, up in the cloud, and that toll-free network, you can have your toll-free numbers being passed down through different paths, okay? So I've got 3 different colored lines there, green, black, red, blue. Green could be Quest CenturyLink, black could be AT&T, blue could be level 3, for example. And providers can actually set it up so your toll-free numbers can work and go down 2 different paths. They can go down 2 different carriers. You can have 50-50 allocation, where 50% of the time it's going down Quest CenturyLink, 50% of the time that number's going down level 3, for example. And depending on the providers that are out there, they could have multiple switches as well, okay? A lot of the bigger providers will have their own central office switches, and they'll have redundant switches that can fail over to each other. That way, if one of their switches goes down, it's not taking you down. It's not taking their customers down. And then the path into the central, carrier A and B. The path into the central, you can then have 2 carriers coming in, one over copper pair, one coming in over fiber. Maybe you've got a fiber SONET ring with another copper pair that you're bringing in. So you can have your last mile redundancy, and you can do that. And then you can also have what's called direct trunk overflow, or DTO, where you can actually have, if a PRI goes down, let's say carrier A in the blue line there is AT&T, and let's say carrier B is Quest CenturyLink. If AT&T goes down, you can have the traffic automatically flow over all of it over to Quest CenturyLink. Okay, that all happens automatic. This isn't dialing a phone number and saying, oh, I need to make a switch and 30-minute downtime. You can do this seamlessly. It's possible to do it. You can also do the failover in such a way that if you've got local PRIs, so if these carrier A and B, if these are your long distance PRIs, because you're doing toll-free traffic, and let's say you've got a local PRI for all your local calling, outbound and inbound voice, and maybe you're also monitoring some local DID traffic as well, and let's say that local PRI in the black line there's Verizon, you can have all of this fail over to the local, okay? There are some limitations depending on where your central station is located, what coverage you have from what providers, but these are the kinds of things that are possible out there today. So now if we want to look at a central station with a backup, this could be a central station that has a backup central or uses the automation as a backup, like Dice or Bold or MicroKey, if you're using one of those services, where you can actually have an automatic or manual failover. And what you can do is you can have your redundancy in the main central station, and let's say your backup site's an automation facility. Let's say it's Dice, for example. And you can have it set up so that if you need to evacuate your building, for example, because let's say there's a gas leak, okay, everybody needs to be evacuated. You need all your signals to go over to Dice. You can actually go online on some systems, or you can make a phone call, implement your disaster mode, if you will, and what it'll do is send all traffic to the backup site, okay? Or maybe you've got your own backup site that's like a warm site where everything's ready to go. You just need like 15 minutes to get your database up and running, do your connections, get some operators over there, and same sort of thing, it could be a manual switch. Okay, or maybe you've got a second site, you've got one customer where they've got a MPLS network between the two, and it automatically goes to the backup site, and he just brings it back across the MPLS, and if he has to evacuate his building, he just does some PBX changes, and he can keep it at his backup site. Okay, so there's lots of different things you can do with PBXs and with your telecom. Dual site load sharing. So this is becoming a little bit more common now. Central stations that are investing in a second site are saying to themselves, okay, if I'm going to invest all this money in a second site, another building, let's see if I can maybe use it to my advantage. And let's see if I can load share and actually take signals to both sites all the time. And it really helps with their operator efficiency as well. We've got customers that will have 2 sites in multiple states. And if there's a storm in one of the states, let's say snowstorm, and they're having problems getting operators in, they'll just bring in more operators in the other state where they're not affected by the weather because they're the other side of the country. And they can load share and take signals from either side of the station. And this site, and this here with load sharing, you can actually have signals. So carrier A is your primary, carrier B in green is your backup. Let's say it's AT&T, Quest CenturyLink again. 50% of the calls can go down AT&T, 50% can go down Quest CenturyLink, so each station is getting 50% of the calls. Maybe one of the stations is smaller, maybe it's only half the size, so you're putting 30% on the station on the right side and only 70% traffic to the left. Okay, those are things that are available. It's the kind of stuff that you can do. And if any of those primaries, like carrier A, goes down, it can always back up to carrier B or to the backup station. Okay, so you can get your redundancy that way in your telecom. All right. So one thing I talked about a little bit is MPLS. How many people in this room have MPLS in their stations? There's a few there. All right. So MPLS is your multi-protocol label switching. It's a mouthful. And what it really is it's a data connection that you can have between your office and your sales offices, and maybe you've got a backup center. And it's a data connection that's got a quality of service on it. So you can bring data across it, you can bring voice across it. It's a secure network. It's kind of like your own extended wide area network, if you will. And there's different types of MPLS. There's traditional MPLS, mesh MPLS, and then we've also talked about redundant MPLS. The people that put up their hand that do have MPLS, do you have just one MPLS connection or do you have two for redundancy? Anybody have two? A couple do. All right. So that's the other thing is you'll have a lot of central stations that might have MPLS, but they only have one MPLS connection into their central station instead of two. Okay, there's different ways to do that to maximize redundancy. And they also have new combo circuits. In the room here, the people that do have MPLS, do you have separate internet connections? You all do. Okay, so it's double the connection. So one of the new things that's being provided out there now are what's called combo circuits. So what it allows you to do is use one connection for MPLS and internet. So for example, you can have a 20 meg connection and you can dedicate 10 meg for MPLS and 10 meg for internet, or 15 and 5, whatever you want to do. And that takes down the amount of connections, and it actually, in a lot of cases, lowers the bill as well, because now you're combining. So if we look at traditional MPLS is really just, usually it's one carrier. Let's say you're doing MPLS with Quest, and Quest is going to be your provider for all your sites. You know, you can have different bandwidths for traditional coming all back to the host, and you typically with one carrier. Now you might have a second carrier that might be your backup that you can implement depending on. Mesh MPLS allows you to use multiple carriers. This is fairly new. There are a lot of big providers out there to do this, and what it allows you to do is allows you to use AT&T, Verizon, Quest. So wherever your sales offices or your other sites are, you can use different networks, and if one of their networks goes down, it's a mesh topology. So let's say AT&T's MPLS network goes down, your traffic's just going to ride Verizon. If that goes down, it's just going to ride Quest CenturyLink, for example, and so on. Okay? So some of the larger MPLS providers out there, they'll have a mesh network that's built with like 30, 40 providers. All right? So your odds of ever being down are very, very, very slim. So if we look at the complete package, and we look at everything here, if we want to look at capabilities, and I use this as a customer that we have. We've got a customer that's got 2 central stations in 2 different states, okay? And this is basically their setup here. So they've got complete redundant carriers coming into 2 different central stations. They have redundant MPLS between the 2 central stations. They've got their receivers and their phone system, PBX, redundant PBX at both sites, receivers at both sites. And what they're able to do is they're able to receive, let's say an alarm signal comes into carrier A on the left-hand side here, it comes down, the system 3 gets it, and it's a 2-way voice alarm. Well, the operator that's in another state is actually handling the 2-way voice, okay, because the PBX is interconnected across the MPLS. So all the operators at this main site are busy. The operator from the backup site can actually do the 2-way audio. Okay, so those are the things that are possible. And that's complete load sharing right through from your data and telecom all the way through. Okay? How many people here have got more than one central station? I know Vector does. And how many people, you're still using both your sites? And what about the other, are you load sharing your sites or just still separate, Anita? They're load sharing, yeah, okay. So it's becoming more and more common. Load sharing the sites, because again, there's so many advantages to doing that. And if you're spending the infrastructure money on a backup site, if you're not using one of the automation companies as a backup, there's some real advantages to it. There's some costs in setting it up. There's definite capital costs, but there's definite advantages too that could outweigh the capital costs in the long run. Okay. So Josh and I, we wanted to make sure we didn't take up too much time in this session. I think we've got 15 minutes left. We want to make sure we left 15 minutes for questions, discussions on anything that we didn't cover, anything that we did cover on redundancy for software and hardware, telecom, data in the central station. Any questions? There's got to be some questions. Come on.
Where to get the BGP? Go back to that and who provides it?
That's a good question.
Who provides you the BGP?
The BGP is something that you would go to, particularly I send a lot of people to ARIN.net, ARIN.net, the American Registry for Internet Numbers. You go to the website, they have the forms there and the contact numbers. You can call up ARIN.net, tell them that you want to get a BGP circuit set up or a BGP subnet set up. You want an autonomous systems number or an AS number. They'll lead you through the forms, you sign it, you fill it out, you send it in, and they send you your AS number with your subnet. Step one. Step two is to find a BGP compatible router and somebody that knows how to set BGP up. This isn't going to be the little network guys down the road. They've probably never seen this. So usually the hardest part is finding a technician that can put this in place for you and know how to do it with the correct hardware. But the first step would be to contact ARIN. And in the area, if it's something that you want to third party out, if you don't have the in-house staff to do it, you really need to ask some of the local network vendors in your area if they can run this particular protocol, if they know how to set it up between your carriers.
Test it out.
And then test
Yes.
it afterwards, yeah.
But you have to realize, when putting in BGP, you're using your existing internet connections, and let's say you have 2 of them. Now, when you put BGP on the one internet connection, the IPs you used to use are no longer available for use. So if you have IP panels, inbound VPNs and things like that, all that goes away on that existing IP structure as the BGP supersedes that now. All right, so a lot of times when I have people migrate to it, what we do is the second internet connection is just there for a backup. We'll deploy BGP just on that circuit and leave their primary circuit alone. We migrate traffic from their existing primary over to the BGP subnet, and once we have everything off that existing subnet, we bring that back into the BGP hookup at that point in time, so you don't have days and days of loss of DNS records, of all the VPNs being down, IP signaling being down.
Where is the outbound traffic for this government? The BGP there?
Correct. The BGP subnet will be the only subnet you will see in and out.
There's a lot of work involved in doing it, but it's worth it in the end, especially everything's going IP.
Yep.
Okay, POTS lines are going to be going away. You got AT&T, and Verizon is now helping AT&T petition the sunset of POTS.
Yes.
So, you know, you might have a copper pair in your home in 5 years, but that copper pair doesn't mean it's a POTS line. It's going somewhere IP. I can tell you right now, central office switches are average 25 years old. Rick's on the ASCC. He's been in those presentations that I have. And Verizon, AT&T, and the rest of them will tell you, well, they'll tell us, that within 5 years, most of their central office switches, they don't have replacement parts for it. They're going to be soft switches. It's going to be IP. There's going to be SIP. So, and if anybody in this room thinks that your alarm signaling that you're receiving is staying TDM the whole way and not being converted to IP at some point, you're fooling yourself. I'll tell you that right now. Okay, so how many people in this room are seeing right now today issues with alarm signals coming through 100% all the time from everywhere? Yeah, everybody, right? There's lots of reasons for that. So IP is going to be, for people that haven't done already, it's going to be really, really important. Alarm signaling is going to be IP in the future. Everything's going to be IP. There's another question in the back of the room before we didn't get to. Anybody? Yeah?
So I believe you all code changed a little bit to kind of help address some of those changes. Can you speak to what you all use in your presentation, like, or what we talking about overkill for a UL standpoint?
So,
or where's that?
So it depends. If you go by UL today, 1981, 827, 864, they're all so archaic that half this stuff is, to them, it's overkill, but it's what's required. Now, the rewrite that's been going on for, I don't know, Anita, I know you've been on the rewrite committee with myself.
It's out in comment.
It's on comment now, finally, but we started it, what, 7 years ago?
Yeah.
So if you look at the new, what's out for comment, there's actually going to be requirements for redundancy on your servers. There's going to be requirements for different things that we've talked about. A lot of the stuff that was in the old stuff about having to have POTS line stuff, that's all going to go away. I know one of the things is DNS is now going to be in the new standard as well, allowing DNS. So a lot of people always say, ask me back in my previous job at Tyco is, well, why do alarm manufacturers make everything static IP? I want DNS, because DNS would make it a lot easier. If you can program an alarm panel to say, communicate to vector.com, then it doesn't matter in the station what you do, it's just going to resolve itself. It'd be great that way, but you will never allow it. So the new rewrite's going to allow that kind of stuff, and it's going to put in, there's actual wording in there that if you're going to do DNS, you have multiple DNS servers and so on. So the new code does have all that. Like Nita said, it's in comment. I don't know how long it's going to take for that to pass and be implemented, but the way things go with UL, I would say a few years anyways. So, yeah. But it's the stuff that we're talking about, it's almost become a requirement now. I've got centrals that we're taking on that, I've got single providers that are down all the time. I've got one customer we're bringing on right now. He's had 16 outages of 2 hours or longer in the last year from his one provider. You can't run a business that way on the central station side, right? Just can't, it doesn't work.
We also have it in the works where UL will work with them to start recognizing the cluster topologies and things like that, remote hosted central stations and things without premise on it. And so we have one central that is UL certified now that is hosted. They're out of California there, and they're running completely out of a separate data center. Receivers, PBXs, the whole 9 yards. There's disaster recovery plans built into that as well. So, and that was the biggest thing. Right now, we've gotten UL to the point where they recognize virtualization in some form, but they said, okay, you have a virtual slice on this machine and another one on this machine, another one on this machine. So you still require multiple boxes, but the true clustering and things, we're still working with them yet because the redundancy is so much better than the failovers.
And there's still a lot of training for UL inspectors for all this as well. So once it is implemented, that's going to be the big part too.
Yep.
Rick?
Probably different. Can you just give me an overview of what you think the expense would be for the solution that he was showing up there?
The full-blown solution of the data?
What do you think that expense would be?
Well,
that's a loaded question.
yeah.
Well, that's why I'm going.
Well, you're talking about one floor. Yeah, that slide right there.
Yeah. Well,
One scare of the slide.
yeah, networks like this, I've seen, people that have a good in-house IT guy build these for, 40, 50 grand. And, it really depends on the size of the network, where if you have 100 end users and only 8 voting parties, like in this picture here, it's going to be one cost. If you have 500 users, it's going to be different. So realistically, the cost of service of network to BGP, the BGP isn't expensive to set up. It's just a pain.
It really depends on how many connections you have.
Yeah.
Part two of this. Looking at that, and then understanding that everything's going to be IP.
Yeah.
I think we're all agreed, right?
Yeah.
We have a low capacity on our receivers, right? The maximum number of accounts we're going to be able to do that. When you take and you look and say, let's take a central station that has 25,000 accounts, what would that look like?
It's going to depend. You know what it's going to depend on if you're talking about alarm signaling? It's also going to depend on what manufacturer receiver they're using, right? Because you've got one manufacturer out there, I won't name names, but you're going to know exactly what I'm talking about, that converts IP to serial using a black box, which is limited. And you've got another company over here with their new product that can do 250,000 accounts of IP in a space this big, okay? So it's a big difference. The throughput on receiver A is probably 100 accounts a minute, where the throughput here is 5,000 a minute. So it depends, and you've got other manufacturers in between. So it depends on how the manufacturers step up their game on the receivers, because that's where the bottleneck's going to be. Today, if you have a storm condition and panels are calling in with low batteries, right? They're calling a number, they might get it busy, they might redial. With IP, it doesn't work that way. I've been in centrals that have 30,000 radios communicating with low batteries, where I've seen them come in all within minutes. And the receiver just takes them all, and then the bottleneck is now the automation. Okay, so things are going to change. So it depends, a lot of it's going to depend on the receivers and the automation as well.
To add on to the receiver side, a lot of the receivers now are going strictly just software, TCP over software, and so we have clustered receivers set up in a load balancing form of multiple servers that can take an obscene amount of accounts compared to what we could through standard POTS and things like that. And that's just across the board. It's just extremely more efficient. And once we have to the TCP level, location doesn't matter anymore. It could be here, it could be in China, it could be in Australia, because location doesn't matter. So that gives, you know, Sasha's company and other centrals the capability to have this kind of flow where you can have IP signaling or signaling coming on these through multiple centers like he was talking about balancing out. So it really comes down to, like you said, the receivers, the automation that can handle that coming in, and then the network to run the whole thing.
Yeah. There's a lot of variables there.
Yeah.
Yeah.
How does IPv6 factor in?
Very good question.
Yes.
So IPv6, I'll tell you right now, I think there's only a couple manufacturers that now have products out with IPv6. IPv4 is what most communicators out there work with, and most can't be upgraded to IPv6. Now the good news is IPv4 is, you can use it across IPv6. It's not a big deal, right? It's backwards compatible. So it isn't that big a deal. The other thing to look at too, if you're a central station today, you can still do it, it's hard, but getting your own ARIN block, so you have your own IP address block down the road, even if it's IPv6. How many stations in here have their own IPv4 or v6 block? One? Anybody else? Two? Okay. So if you've got your own ARIN block, and I know there's a lot more central stations out there that have their own ARIN block than I realized. I've only learned in the last year just how many really do have it. For them, it's great because using their own ARIN block and using BGP routing, they're not tied down to any data carriers. They can move data carriers whenever they want. They can move building sites. They don't have to go out and reprogram panels ever because they own those IP addresses that are programmed in the panels.
I've actually received many calls from central stations that either their ISP got bought up by a larger one and they're losing their IP space, or someone called me up saying, Josh, you know, my carrier's really raking me over the coals on cost here. You know, what do I do to help get the cost down? Because I got 10,000 panels coming in on this line. With the BGP, it doesn't matter. If one carrier raises their costs or they're not treating you well, or the service isn't good, you get rid of them, bring in any new carrier and just re-advertise BGP on it completely transparent without any changes to your IP panels or anything out in the field. And so it allows you just kind of just chug through them as you see fit. Nicer connection comes along with a better pop, a shorter last mile with better redundancy. You can move right to it and just re-advertise and you're done.
Any other questions? Maybe a couple minutes, yeah?
What applications do you guys leverage to track uptime, like SolarWinds type of applications that would recommend?
Uptime on the network, the data network?
I prefer Nagios. I do use SolarWinds. SolarWinds, I like to use more of a diagnostic approach into the networks. When something's wrong, I need to look at it. Nagios works pretty good. A lot of the large medicals I work with use a program called What's Up, and they really like that program as well. There's other ones out there like Servers Check and things, which are a little small, and they're not really made to scale to the larger sizes like that. If you got a little LAN, 10 machines, something like that's good, but primarily it's Nagios, Nagios.
We've got time for one more question. There was one hand.
Yeah, I have a question. Do you currently go BGP to own your IPs?
What was the question?
For BGP, do you need to own the OP? No, you don't need to
own your IP.
own the IPs from ARIN. With BGP, you're getting the BGP service from ARIN, right?
Yeah, well that subnet gets given to you, so it actually belongs to your company. Yeah, from ARIN.
If you don't, you're going to route those.
Yeah,
Yes.
if you currently don't, yeah, then you're going to route BGP to your existing carriers.
I don't own the current one.
No. All you.
I own the ones from ARIN, I understand.
Yeah.
I don't know.
But when you acquire your ARIN block of IP addresses, your existing IPs on your two internet connections are used just to advertise the ARIN block. That's it. So if you're given 5 IPs on this connection and 5 on this one, you're just using those IPs to route your /24 from ARIN is all. That's why you can't use these. Exactly. Yep. So you know what we run is I run dual fiber sonnets coming in to HSRP routers. I have 2 /24s from ARIN, so I'm actually using both circuits. Because when you're routing BGP under a single /24, you can only use circuit A. Circuit B just sits dormant until it fails over to it. What I've done is I've taken 2 /24s, route one out this one and one route out the other. If this one fails, both of them route back to this scalable fiber here and vice versa. So I actually utilize both my internet pipes because you're paying for it per month anyway. So I might as well utilize it. It's much cheaper. Exactly. Yeah. So the problem with getting two of them is you actually have to justify the ARIN the INA, why you need a second one. So you can't just open up the hand and say, I need 2/24, they're gonna say no. Yeah, they want it justified. Yeah, for me, it was hard because most of my IPs through Aaron are actually bound and advertised through IPsec tunnels. So it's not publicly addressable, but they are all used up. So when I justified for my second, I had to go through a long, lengthy sheet form to fill it all out and what everything's doing to justify my second one.
We actually have a little bit more time for questions than I thought. We got another 5 minutes. Any other questions? Things anyone wants to discuss about?
I like that slide.
Which one?
It was just on the server, the clustering. You were showing server clustering. What clustering type are you going to use?
Well, we use a series of different clustering. Most of the time, you can use like a Mongo database system that clusters across as many nodes as we want. It's very easy to use. The load balancing works well. On the other side of cluster,
Load sharing.
yep. Now, what we've done is the servers themselves, it's not necessarily a piece of software I put on the servers. Mongo is more of a database that transgresses through multiple people and saying it gives some to you, and automatically does that. Other scenarios like this, you can use load balancers. Coyote Point makes a good load balancer, so do a bunch of other ones. And what's nice about load balancing like that in a clustered environment is if I have here, I have 8 voting parties in these 2 particular clusters. If I need to do maintenance on one, and let's say it's serving out web requests to your end users and dealers and things for web access, I need to do upgrades. What I can do is you can tell the load balancers to stop sending requests to these servers here, and it will offload it to these other servers. So once these servers, all the requests are gone, it powers them down. And then notifies IT you can upgrade these servers. Then what you do is after you upgrade and you bring it back into the cluster, you tell it to start paying off all the traffic back to these guys. So as end users fall off and new requests come in, they go to the new set of servers, then the secondary set gets shut down. So you have a continual uptime with load balancers like that. You can also set it up on load balancers to where you have 4 servers at a location, but you only need 1 run or 2, let's say. Utilization, it's 80%. The LBs will just start waking up additional servers automatically to contain that load, so you're always underneath 80% capacity before there's service degradation. So it really depends how you wanted to do it. We're actually working on it right now to get UL on those. We're a couple months away before we get a signature on those. We have them out in the field. Like I said, we just got certified UL for our first hosting center that's completely hosted a few months back. So as we slowly work through it, it's not the easiest thing to make UL move fast.
Right.
No. No.
Any other questions? Yeah.
Do you have a sense of what are in our industry, what a good uptime number is? I mean, are good central stations that you work with, they have 5 nines uptime, or would you dare to recommend that Scannon would be the top, the best companies versus those that maybe aren't?
Instead of 9s, I normally see people equate that into the amount of time per year they're down. Because you can mathematically figure that out. And so a lot of customers don't want to be down any more than a half hour per year. And it's really the comfortability of the executive staff at the company and how much money they want to put into that to guarantee that kind of uptime. Normally what I see is anything below a half hour per year is pretty unacceptable.
Yeah, and you won't find in any telecom contracts or data contracts anymore an SLA that says 5 nines of service. That's all gone.
Yep.
What you'll find in there a lot of times is that you have to give them a certain amount of time to be back up and running. If you really fight with your provider, you can put stuff in your contract that gives you outs. Like if I'm down X amount of time, more than once a year, I can get out of my contract or something like that. You have to fight for that kind of stuff because they don't want to let you have that. But that 5 nines is gone. I would say though, if your central station has got good redundancy on their telecom and data, their networks are set up right, they shouldn't really have any downtime. It should be 0. It really should be. If you're down more than half an hour a year, then you've got some redundancy flaws. So then it's up to you, how much money do you want to spend to make sure you don't have that headache, right? That downtime, what's it worth to you? That's really what it comes down to. And a lot of the times what people don't realize is when you add redundancy, you're not necessarily adding costs. A lot of customers that we add redundancy to, we're not adding any costs. A lot of the times their bills end up being the same on the telecom and data side. So there's different things that you can do. There's ways to save money and ways to be more efficient by doing it. Same on the data side. There's probably some capital, but once you've spent that capital, you're going to put that over a couple of years. You know, it ends up paying for itself with no downtime.
And to address back to your question on the cost of BGP and to lay these things out, you know, I've spent upwards of 16, 18,000 per router to do a lot of traffic. I've had other customers that literally went on eBay and just spent $100 on a couple Cisco 2600s, threw them in there and started routing BGP, and it didn't cost them no more than $400 or $500.
Rick's laughing. Is that what you did, Rick? So, yeah, and that goes for a lot of things out there. I mean, there are ways to do it and give yourself better redundancy and not have to. You don't have to spend a ton of money to do it.
And a lot of times I see centrals that already have the equipment. They purchased it out of recommendations from their IT company or their IT staff that did not realize the equipment they already had can do exactly what they want it to do. You just got to turn it on.
Yeah. They're just not utilizing it. I've seen centrals that have their own errand block and still aren't using it.
Yeah.
They've got it just sitting there because they just don't know where to go to implement.
Mm-hmm.
And that's the biggest part. Once you get your own block, that's the hardest part. After that, it's pretty easy. So, you know, it's making sure that what do you have? Look at what you've got, right? Go through your checklist and see within your station, what do you have? Are you utilizing everything you can be?
And when it comes down to the time where you have your errand block, you have your AS number, you have 2 internet connections, you talk to a tech, all you got to give them is, here's my IP block from Aaron, here's my AS number, here's my 2 internet connections. That's all they need. And they literally put the router in it, program to the 2 connections, set up the BGP subnet, start advertising autonomous systems. And the autonomous systems, if you didn't know, advertises to the global routing tables on the internet. That's why you need the AS number. That's why you can have the IP redundancy in between an X amount of carriers, is you're actually advertising to global routing. I'm no longer here. Don't take this highway's down. Take this detour highway to get to me. And the internet routes will take about 5 minutes to triculate around the world. When I fail BGP over, I personally see anywhere from 5 to 10 seconds of downtime as it flips. I'll see all my VPN lattices drop, and I'll see them all come right back up. There's literally nothing we change.
The other thing with IP too, you know, Josh talked about how quick it is and everything going IP. Doesn't matter where in the world you are, you're going to be able to start monitoring accounts in other areas. There's a lot of U.S. central stations monitoring Canadian accounts and vice versa. There's U.S. stations that are now looking at accounts down in Latin America that we're working with. I personally have done tests where I was in South Korea sending IP signals to Toronto and back, and they were taking round trip less than a second. So, I mean, it starts to open up a lot of doors for you for other areas and other markets as well.
We have a lot of centrals now that actually get VTNs or just local presence numbers in a whole different country, a different state. And the VTNs actually broadcast the local numbers on the out dial. So someone sitting in Spokane makes a call down to, I don't know, let's say Mexico City. It pushes out that local call ID through VTNs because there's a presence there. And that gets more like what Sasha does, where he can provide those kind of services. So location, like you said, really doesn't matter. Not for inbound numbers or outbound numbers or IP signaling anymore. It's all pretty much seamless now on the location where it can go.
Any other questions? No? All right, thank you, everyone.